Started. Welcome to this first session of the day called PowerShell Desired State Configuration, Real-World Experiences, where I'm going to show some details about how we have implemented DSC in a production environment. My name is Egil Ring. I work at the Crayon, a consulting company in Norway, as a lead architect in the infrastructure department, where I focus on automation in addition to infrastructure such as Hyper-V and so on. I'm a cloud and data center management MVP, formerly Windows PowerShell. It was consolidated into lot smaller much bigger categories last year, so that all of these smaller areas was moved into, for example, cloud and data center management. I'm also an author and contributing editor at the PowerShell magazine, the Crayon Services blog, and the TechNet, Norwegian TechNet blog. You'll get more information at the end of the presentation about the URLs to the slides and contact info for myself and so on. So in this session, I will share information about how DSC was implemented in production in two specific scenarios at a customer. In the first scenario, the project started based on PowerShell 4.0. This project, I believe, started in 2014, so PowerShell 4 had been out for like a little bit less than a year. That was the latest version available at the time. We'll look at the specific scenario, as well as how we integrated DSC with other products such as System Center Service Manager and SMA, or Service Management Automation, which I'll show you. An important concept around configuration management in general is how we handle the configuration data. The configuration data can be, for example, what server roles to install on a server, what IP address should the server have, and so on. So it's important to note that DSC itself, it's not a configuration management product such as Chef and Puppet and all those others you might have heard about. So if you're going to use DSC without any product on top, you'll have to do a lot of customization yourself, for example, creating PowerShell modules, scripts, and so on. So that's what we did in this case. We actually did use Ansible for the Linux side of things, but not on Windows. So what we currently have, I think it's a step in the right direction, as you'll see, but I'm sure there are lots of room for improvements. And I'll discuss a little bit in the end of the session where we're at and where we're hoping to get. And in the second scenario, I will show you how we use DSC integrated into a virtual machine deployment project. An important part of deploying virtual machines or servers in general is, of course, deploying the operating system, but what's even more important is what's happening after the operating system is installed. So I assume that many of you have some manual routines and that you have some instructions on how to go in and manually configure a server, but the goal with the configuration management is that you shouldn't have to do anything manual. It should just be handled by the configuration management solution. So before we get started, how many of you have heard about desired state configuration before? About over half of the room, I guess. So that's very good. It's been out for over 2 years now, so it's really time to start looking at it. But just a quick recap for those of you who haven't heard of it yet. About what it is. You might be accomplished to an imperative syntax when you do regular scripting. You tell the script exactly what to do, for example, how to start a service and so on. That you, for example, run start service spooler to start the print spooler. But in the declarative syntax, you just state what you want to accomplish. For example, you state print spooler equals running, the print spooler state. So it's kind of a different mindset you have to wrap your head around before getting into it. The other thing is that the idempotence, so it's tested at specific intervals. For example, every 15 minutes, the server will check if it's in the desired state that you said. For example, that the print spooler should be running. Should also note that this is a standards-based technology. It's not some proprietary Microsoft technology, even though it's called PowerShell Desired State Configuration. The underlying technology is actually using managed object format is the file format. So it's basically just text files, as you might have seen on Linux, for example. So it's supposed to work not only on Windows, but also on Linux, network devices, storage devices, and so on. But the PowerShell language have some extensions that makes it easier to define the configurations, so you don't have to write those complex MOF files yourself. So that's why it's called PowerShell Desired State Configuration. And I also guess that many of you have some automated provisioning routines today using Configuration Manager or some template in VMware or Hyper-V Virtual Machine Manager or something similar, where you configure and install things from a checklist or on demand. So the goal here is that you should get consistency. You should not get what's called snowflake servers. If some person is configuring one server one day and the next day your colleague is supposed to configure an exact same server, it's not getting 100% right because he was distracted or getting coffee and forgot something. So the goal is consistency and keeping servers in a known state. So an analogy to look at this is a car assembly line, where servers come out of an assembly line and get applied. For example, instead of cars which have different models, you can have servers with different roles, such as a web server, domain controller, database server, and so on. So here all the configurations necessary for a role is predefined. So if it's a web server, for example, maybe you should install Apache or Nginx or IIS if it's Windows. So you can rule out basically non-default configurations which might cause problems. For example, imagine that you're an administrator who are troubleshooting some problem, and then you're searching on the internet, finding some solution to, for example, change a registry setting, and maybe it solves the problem, maybe it doesn't. But the goal is that, the case is that the registry key will still be there, and it's a non-default setting that should not be there. So if things like that happen, the thought here is that we should use more of the same strategy as we use on client computers. If it doesn't work, spend 15 minutes troubleshooting and just re-image the computer. That's the goal for servers as well. Just redeploy it and apply the same configurations. And if it's a highly available service, you probably have several servers in the pool, so the users shouldn't notice that one server is being redeployed. That's the high-level goal of desired state configuration or configuration management in general. So the customer background for the two scenarios that we are going to look at here, both scenarios was built for a customer in Norway that have a number of production plants spread around the country, about 5,000 users, about 1,000 servers. The main platform on servers is Windows, but we also started deploying more and more Linux in the later time. Hyper-V is the primary virtualization platform, although there still are a few VMs there. And we also started to leverage Azure infrastructure as a service, basically virtual machines running in Azure for test and development machines. So the first scenario we're going to look at is deploying Hyper-V hosts. Physical servers was being replaced on the production plants. Typically it was only one physical server that was running software on the physical host. So the project started out by designing how to replace those servers and also get high availability. The larger production plants, of course, got maybe a SAN or a cluster of Hyper-V servers to get high availability, but most of the small and medium ones, that was a bit overkill to deploy that infrastructure there. So it was decided to deploy 2 physical servers, both running Hyper-V, and then use Hyper-V Replica to replicate the virtual machines from the primary server to the secondary server. So we have fault tolerance for hardware faults. And also the reason that the servers had to be deployed on the production plant was that the production plant should keep running if the communication to the data center went down. So here we started out by building an automated solution for deploying both of these servers. Also, we wanted to deploy 3 standard virtual machines, 1 database servers and 2 application servers. And at the time, as I mentioned earlier, we were using PowerShell 4.0, which was built into the operating system on the Hyper-V hosts. So both VMs and Hyper-V hosts was based on 2012 R2. We used Service Manager as the configuration manager database. I'm going to show you a little bit more of that. We used a third-party add-on from Cyrison on top of Service Manager to get an HTML-based portal that's not having dependencies on Silverlight and SharePoint, such as the built-in one. Then we used Service Management Automation, which is a part of the System Center 2012 R2 family. Its installation files resides on the orchestrator ISO file. SMA, how many of you have worked with SMA here? A few people. As you probably know, it's based on PowerShell workflow. So instead of regular PowerShell, where you can just write functions and things you're used to in PowerShell, you have to use workflows, which is a little bit more complex because you have to know the pros and cons of workflows. It gives you a lot of advantages when doing long-running tasks, for example, and the ability to resume things that fails and so on. So there are a lot of pros, but also we run into a lot of complex scenarios and a few bugs. So it was a little bit difficult, but we got there in the end. Also, before I go showing you the solution, I'm going to talk a little bit about the terminology here. It's only that slide. Very strange. But I'll try to talk you through it. You can download the slide afterwards. Basically, we had this terminology where we had a site on the top, which defined the physical production plant. Under there, we had what's called an instance. And an instance might be either a single server, it might be 2 Hyper-V servers with Hyper-V replica, or it might be a cluster with several Hyper-V hosts, for example. And below an instance, we of course have 1 or more Hyper-V hosts. So that's what I was going to show you in this flapping picture, that you have site, instance, and host, and some example of that. Here is an image of the front end from the Cyrison portal. So this is basically the steps that the IT operators had to go through when deploying a server. The first step to do is, of course, to register the servers to the system. So the 3 bottom steps, you first have to register the site. It contains information about IP ranges and site-specific things. Then you have to create an instance, which is, in this case, 2 Hyper-V servers. And below that, you have to create 2 Hyper-V hosts attached to that instance. So on the servers is registered in the system. When you register the Hyper-V host, you also register the integrated lights out address. It was deployed on HP servers in this case. Then the system have all the information necessary to automatically deploy the operating system, install Hyper-V, configure the servers, and so on. So when everything is ready and the physical service is attached to the network and the ILO address is reachable, the operator can start to deploy the solution. So we defined it into 4 parts instead of having 1 big red button called deploy. We divided it into several parts so that we can go in between each step and do some manual checks that everything is okay. So the first step will deploy the operating system on the Hyper-V hosts. The second step will configure everything related to networking. So for example, in Virtual Machine Manager, it will deploy all the virtual machine networks and Hyper-V switches and things like that. On the third step is where the Desired State Configuration integration came into place. So here it will configure Hyper-V specific things, such as what disk should the virtual machines be placed on. It will configure the data disks used for Hyper-V and so on. But also here we deployed the Hyper-V DSC configuration, which will ensure that things stay in that way after the deployment. And the fourth part is deploying the 3 default virtual machines. I also have a screenshot from the Service Manager console, just showing you some example of the Cyreson views where you have the host, instances, and sites. So here you see some examples of the properties you see on a site, IP ranges, if you have local DNS servers, for example, the instance where it shows replica for all deployments in this case. You can also override the default names of the VMs. So it's a manual task to check that these are not in use before starting deployment. In the next project, the VM deployment project, all names are generated automatically that I will show you. And then you have also the host-specific settings. For example, these properties we are getting when building the DSC configurations so that this group is added to the local administrators group, for example. So if someone removes this group, DSC will automatically add it back to the administrators group after 15 minutes, which is the consistency interval in our setup. Before I show you the demo about the first scenario, a little bit information about the DSC integration. As you probably know, there is a DSC client on the servers which have PowerShell 4.0 or later, called the local configuration manager. So one of the steps is to configure the local configuration manager for either push mode or pull mode. In this case, we used a pull server so that every Hyper-V server got its configuration from a central pull server. Then you can easily just update the configuration on the pull server later on. You don't have to push configurations manually to each server. So in our setup, we have an IT pro sitting on his computer, deploying or creating a DSC configuration, which I will show you an example on. That will generate a MOF file, which I talked about earlier, which is the open source file, if you will, that will work cross-platform. That MOF file will need to get deployed to the DSC client. So when testing, you can use start DSC configuration to push it and ensure everything works. But in our case, we used a pull server, as I said. And the MOF document needs to be placed on the pull server, and that is something that is happening automatically by SMA in this case during deployment. So on step 3, during the deployment, an SMA runbook will run and inject this MOF file on the pull server. It will also configure the local configuration manager to talk to the pull server and pull down the latest MOF file, so it will be configured to the desired state right away. Then I'm going to go into the demo for this scenario. Let's do duplicate so you can see as well. So in this case, what I didn't mention on the last case was that we also use Git for source control. So when you're working with a large project like this, you have pretty many files, PowerShell modules, configurations, functions, and so on. So it's, in my opinion, essential that you use some kind of source control. So in our case, we used Git. So what we're looking at here is using a free open source editor called Visual Studio Code. It has nothing to do with Visual Studio, but it's an editor which supports PowerShell and many different languages. So what I did here was basically to just open a folder in Visual Studio Code so that I get all of the folder structure shown on the left-hand side. So it's basically the same as I see when I go into here. It's just a folder structure that I navigate through. It's much easier than using Explorer when working on it. So I'm going to show the most essential parts. I'm not going to go through everything here. All of this repository is on my GitHub account, which you can find on I'll tweet a link afterwards if you're interested. So here we have under Crayon DSC configurations. This is from the Crayon demo environment where I configured the same solution as we did at the customer. So the DSC local configuration manager, that's basically the script that we use to configure the LCM or the DSC client. Let's see if we can get it to open. There we go. So here you can see the DSC keyword at the top, configuration, give it a name, and we configure the properties. So here we configured it, we hard-coded it actually to apply an autocorrect, so that if something is not in the desired state, it will just go and fix it. You can also set it to, for example, apply and monitor, if you just want to apply it the first time and then only get reports in the event log if something is not working. Here you define the intervals for when the server will check with the pull server if a new configuration is available, and also how often the DSC client check whether everything is in the desired state. So this is the template that we used for automatically deploying the client settings. The next one is with the Hyper-V configuration. So if you look at the top here, you can see, again, we specified the configuration keyword. We gave the configuration a name called Crayon Hyper-V host. So this is the default settings for all of the Hyper-V servers deployed through this solution. We also have some custom DSC resources. A DSC resources is basically what will go under the hood and do the things that you say. So if you say that the spooler service should be started, it's a DSC resource called service that's built into the operating system that will do the actual work running start service, for example. But in this case, we are using resources that is not built into the operating system. We are using some that we got from the DSC resource kit, which have like 200 resources, a little bit more than that, which is available open source on GitHub. And we also deployed or created some custom DSC resources specific for our environment. So here you can see that we divided the configuration into several parts. For example, the base OS config. It's a composite configuration, so that this part is actually running a composite configuration that will configure a lot of things that I will show you in a minute. So it will configure base settings that will be applied to all servers, basically. It's a base config that we want all servers to have. Next, we have Hyper-V specific things. So here we are injecting information about, for example, the local administrators group. This variable we get ultimately from Service Manager, the field that you saw earlier. And for example, things like where to place Hyper-V virtual machines, disk files, and so on. This is a custom DSC resource we created for setting up some performance data collector that will run for 12 hours every week and store the configuration data to a central server so that we have some baseline of the performance. Further down, we have, this wasn't used in this project, but if it was a cluster mode instance, we could install failover clustering, for example. We can also have some hardware-specific things, so that if it's a HP server, we can do things related to that. In this case, we are installing, we are configuring SNMP, and we are installing an HP software that will provide some more WMI classes, so you can use PowerShell to gather information about HP-specific things from the servers. So this is basically the configuration that was generated and applied to all new servers deployed. Then we have some information about the configuration data. If you're used to using DSC, you might have seen this PSD1 format where you can define configuration data in PSD1 files. In this case, we actually used JSON, which is a different format for storing data, basically. So we have a function that will read the contents of this JSON file from the Git repository and present it back as a PowerShell object. And it will also check for the domain FQDN that you're running it from. So if you're logged on to some machine in the demo.crayon.com environment, you will get all of this information back. If you run it from the test environment, you will get different values for what to use as a DNS server and so on. So if you go into, let's have a look at this file, where we have this get environment data function that I created that will basically read information from that JSON file. And then we store it in this environment data variable. So if you have a look at the contents, you will see that the information we get back here is all the data related to the demo environment. So if I run this from another Active Directory domain called test.crayon.com, I would get the values for that domain. So in the scripts that we have created, we haven't hard-coded a single value for example, the DSC pull server. Everything is configured in this JSON file. So it makes it very easy to reuse the same scripts from environment to environment. Imagine that you're a consultant, for example, and you reuse this on several customers. You can just create a JSON file for each customer and basically use all of the same PowerShell scripts in different environments. So that's the configuration data. Also, we got some of the configuration data, as I told you, from Service Manager, such as the Hyper-V local administrators group and so on. But the common data we store in this JSON file. Let's also have a quick look at the composite modules. I showed you earlier that we had one for base operating system, for example. So what a composite resource basically is that you can specify or group configurations in a separate file. So here, for example, I have some firewall rules. I want to enable remote desktop, for example, allow ICMP or ping, allow file and printer sharing, configure the Windows Update mode, and enable RDP. So instead of having all of this 70 lines in the main configuration, I separate it into a dedicated one. You can just think of it like group policy. Instead of having all your settings in one huge group policy, you separate it out to several several group policies. So there is the base one. We have the Hyper-V configuration, where we specify if you don't get, for example, a path from the central service manager CMDB, we'll configure it to see Hyper-V by default. Here we set some Hyper-V host specific things, such as enabling enhanced session mode, how many storage migrations to allow, and so on. So this is basically Hyper-V specific settings. And also some registry settings related to Windows Update and things like that. So that's the DSC configurations. Then we have a DSC helper module, where we have all of these helper functions. Because I told you that this is not a configuration management product. It's a platform that we're building upon. So we need to create some things ourselves. For example, the get environment data function that will basically just use invoke REST method and get the JSON file content from Git. Things for publishing a module to the DSC pull server, test if PowerShell remoting is enabled, things like that. Then we have the SMA runbooks, which is what's called in step 3 when the Hyper-V host is being configured. So it will basically run 2 runbooks. The other ones are kind of helper runbooks. The first primary runbook is deploy Hyper-V DSC configuration. This will basically get a bunch of global variables from SMA, where we have a variable store. Then it will go through different things, such as importing the configuration, and then it will do a for each Hyper-V host that we get from Service Manager. It will check if PowerShell remoting is available. If so, it will run a function to get the encryption certificate, because we need the thumbprint of the certificate on the target host, which will be used to encrypt credentials. When that's done, we can see that it will run the configuration. So here we can see Crayon Hyper-V host, which is what we saw. If we go up here again, and we open this one, you can see here is a configuration Crayon Hyper-V host. That will be a command that is available in PowerShell. So that is basically what we are calling here. So all of this configuration is being applied to the pull server in this case. So it will generate a MOF file that will be stored on the pull server. When that is done, it will create a checksum file, which is also needed when working with a pull server. And next, it will call a different runbook that will configure the DSC client. So this will actually apply the configuration that we see here, the LCM configurations. If we go a little further down, we can see that it will run DSC LCM pull settings. That's the document that I showed you in the beginning. and then it will run setDSC local configuration manager to apply it to the node, and then it will actually get the setting so it know what the URL to the pull server is. And at the end, we run update DSC configuration so that it will get to the pull server right away and download the configuration. If you don't do this, it can take, I think it's 60 minutes or something like that until it will download the document. So that's basically the first project. I see that we're halfway through, so that's a good time to get started on scenario 2. Just mention briefly before we go further the current state of what we were. I also presented what you have seen until now on the PowerShell Summit in Stockholm in September. So this is basically the state of the union at that time. So the goal at that stage, when PowerShell 5 was not released yet, it was in a production preview. It was to increase the PowerShell knowledge of the customer. So we had a workshop last fall where we had all the operations guys attending, because you really have to get know PowerShell to use it this way. If not, you should look at maybe using our configuration management product instead. But if you're going to use DSC from that product as well, you need to know some PowerShell. So the PowerShell knowledge is an essential factor. Then the goal was to build some simple DSC templates for the application owners, for example, for different server roles, as I mentioned. We also wanted to look into Azure Automation DSC, which was a new feature at the time. We also wanted to think about the robustness, for example, create tests using testing frameworks such as Pester, use a build server, but those are things that are very long in the future. You don't start there. You have to start simple and just add features going forward. We also wanted to migrate to PowerShell 5. As you know, DSC is a part of PowerShell, so there are a lot of new features available in PowerShell 5. So we wanted to leverage new features there, such as partial configurations, where you can have some people configure the OS settings, some people configure the role-specific settings, for example. So let's move on to the second scenario, which is a VM deployment project that is some ways pretty similar, but instead of SMA, we started to use Azure Automation to deploy virtual machines. And the virtual machines we are deploying, it can be to on-premise, to Hyper-V, it can be to the cloud, to Azure, for example. It can run Linux, it can run Windows. It's basically the goal was to create a robust solution that you can use to order virtual machines, no matter the operating system and where it should run. So here I can show you before we start to show how the portal looks like. Just go in and order a VM because it will take some time, so it can just run while we talk. So if you go into this server, I'll show you the Desired portal where the user can order a server. So here we have, let's see if you're still logged on. We have an offering called the Order VM. It's in Norwegian, but it means Order VM. So basically, when I click on the Order VM offering, I will get to a new page where you have a few options on what you want to order. For example, do you want the virtual machine to be a test, a development, or a production machine? And also, what are the role of the machine? Is it a database server? Is it an application server? And so on. So if you go into the request ordering, here I see this top create on behalf of, because I'm an administrator, but a regular user would only see these two parameters, which is also in Norwegian. This one means environment, so we can choose development, QA, or production. So if we choose, for example, dev, on the next one I can choose what role the server should be. For example, a Windows General, Windows Print. We also have Linux in the customer's environment. And if I choose on production as the environment, you will see that I get some additional options here. So that's what's new in the 4.0 preview version of the Saracen portal. So if it's a production environment, we will get asked what to back up or what to monitor, for example. This isn't implemented yet, it's just a proof of concept, but maybe we could have a drop-down menu to see, for example, full backup, backup of data disk, D, E, and F, for example, and what the ports to monitor. So this is something that we have not implemented yet, but we have, because we are waiting for the final version of the Saracen portal. So if we just say something, and we hit save, then what will happen in the background is that it will kick off a runbook that I'll talk through in the next minutes. So the infrastructure is pretty similar to what you saw in the first project, where we used the Service Manager as the CMDB, we used the Saracen portal on the top, but instead of SMA, we are now using Azure Automation. And the two main reasons that we are now using Azure Automation instead of SMA is that, for once, I don't think SMA is being developed much more. They are focusing more on Azure Automation, and hopefully it will get available on-premise as part of Azure Stack, maybe, I don't know. But the main part here is now that instead of PowerShell workflows, it's supported to use native PowerShell, so you don't have to use workflows anymore. So if you're familiar writing PowerShell scripts, it's very easy to get started with automation. And the second, so this was a feature that was added to automation, I believe, last fall. The same with the hybrid worker. Earlier on, when you run books in Azure Automation, you were not able to run them in your on-premise environment. So you could not hook up Azure Automation to a VPN tunnel down to your data center, for example. But this new hybrid worker role in Azure Automation makes it possible to run runbooks on-premise without any VPN or anything. You just install the Microsoft monitoring agent, which is the same as the SCOM agent, on any on-premise machine. In our case, it's a 2012 R2 machine, and you run a PowerShell command to register the server as a hybrid worker in Azure Automation. Then you can basically run runbooks on this hybrid worker and do actions on your on-premise environment, such as Virtual Machine Manager to create a VM. So what we did in this case was that if it's a production environment or a development environment, it will create a virtual machine on-premise on Virtual Machine Manager on Hyper-V. If it's a development or test machine, it will create a virtual machine in Azure. And also regarding the approval process, if it's a production machine to be deployed in VMM, some operator would need to approve it so that the users can order as many as they like. But if it's a test machine, you don't need to approve it. But that's something that you can configure in the configuration. But at least that's the high-level thought about this. Next, we have a little topology about how the flow in all of this is. So if you look at the left, where you order the VM and you select either environment and type, for example, a production VM, which is a Windows server, it will go to the second step, which is to define the OS based on the type. So for example, if it's the type is Windows General, the OS will be Windows on 2012 R2, for example. So this is stored in a mapping table, which is basically also just a JSON file that we can read into PowerShell as an object. So it will define the OS. Next, it will automatically calculate the name of the virtual machine. So there we created a small name registration service. It's a former colleague of me, Trond Hindnes, who built a lot of the underlying components in both of these projects. But I was involved in both configuration management and also different parts of it, for example, deploying to Hyper-V. So he built this simple web service to register a name. So in this part, it will go out to check based on the customer's naming convention what the next available machine name is in a given range. So it will check DNS, Active Directory, Virtual Machine Manager, Azure, all of these things that you check that when you manually want to find a free name. So it will basically get the next available sequence in a given range, for example, application server O2. Then, if it's a production environment, you need some approval, so the automation will stop and wait for the approval. If that's okay, it will start the deployment. But if it's a test or development, you can just go directly to the deployment. And from there, we have some rules where to deploy it. For example, on-prem if it's production, Azure if it's dev or QA. So basically, it will run different scripts based on if it's VMM or if it's Azure. And if it's Azure, you need to deploy to, for example, a cloud service. We are not using the new ARM mode yet. We're using the service management mode still, where you need to use a cloud service and a storage account. So all of these things will be handled by those deployment scripts. If it's VMM, a different runbook will be run. And it will also configure static IP addresses for all deployed machines. So here we are integrated. We are using IP pools in Virtual Machine Manager. And we're also getting the IP address from the customer's IP address management solution, which was men and mice in this case, but it could be any IPAM solution that supports some kind of interaction with automation, such as PowerShell. Then we get to the interesting part in this case, which is the configuration part, where if it's Linux, Trond configured the Ansible integration, where some playbooks will be run based on the server type. So for example, for one role defined, which should be some web servers, it will go ahead and define some default settings for using Ansible. If it's a Windows machine, it will use Azure Automation DSC. It will hook up the virtual machine or the server to Azure Automation DSC. So in this case, we are not using all on-premise pull server as we did in the first project. No, you can actually use Azure Automation DSC as the pull server. The benefit there is that you get a portal where you can see the DSC clients, you can see the configurations, so you don't have to run any PowerShell commands to interact with it, on a high level at least. And then we also have some other scripts that run at all times, if it was Linux or Windows. For example, it would register the VM in the production DNS or register the machine in Service Manager, for example, so that you can get all machines into the CMDB, even if it's a production or test or a different domain that the Service Manager server resides in. All servers will be registered. So basically, it will register it back to the CMDB, and it will say that the deployment is complete. At the top here, I also forgot that we deployed some notifications, for example, to email or to Slack, which is a communication channel. We also used Windows Management Framework 5. We started testing this project on the production preview. Then they came out with RTM in December, but that was pulled because of a rather nasty bug, which polluted the PS module path. So that, for example, if you had some PowerShell modules installed, which was added to the PS module path, PowerShell wouldn't find those modules using auto-loading because it was reset to default. So it's still not available. They are saying that it will be available sometime in January, February. So I guess any date now it should be re-released. But basically, we just use still the RTM version that was deployed because we are deploying to new computers, so the bug doesn't affect the new machines. We are deploying that RTM version. It's also built into Windows 10 from build 15.11 from November, and also Windows Server 2016 that will be probably released sometime in Q3, I believe. And they also deployed it down level to Windows 7 and back to 2008 R2 actually. But in this case, we are only using DSC on new 2012 R2 servers, so it's only greenfield deployment. We haven't decided, or I don't think it will be that we will deploy it to existing servers because there are so much to think about. For example, compatibility with the PowerShell 5. You can't just install it on some random production server and cross your fingers. So we are basically just started using it on new servers, because it would be a very large project to deploy to existing. but you got to start somewhere. You could start deploying to existing if you have the time. And then we can also get access to all of the new DSC-related features, partial configurations that I mentioned. Also, you have some features regarding internode dependencies. For example, you can imagine that you're spinning up a new test environment. Then you can say that the server B shouldn't continue with its configuration until the domain controller is up and running. Things like that, you can define dependencies cross-computer. Then, before we go into the last demo, I have a slide about Azure Automation. How many have seen or used Azure Automation in this room? Maybe 10 people or something like that. This is really something, at least for those who are already using SMA, I would recommend to have a look into, because they are constantly adding new features. And after the support for native PowerShell and the hybrid worker, it's really starting to get very useful for real-world scenarios. So it's basically an automation and orchestration engine, and it can be a DSC pull server replacement as well. You can see you have DSC configurations and DSC nodes. I believe there is another session at NIC which will go into the details about DSC from Alexander. I'll show a little bit high level, but he will go into the details. Also here you can configure the hybrid worker and see all of your runbooks, your assets. That's basically can be variables, it can be credentials for connecting to VMM, it can be a lot of things. And the jobs, when a runbook is run, it will generate a job. So let's go and look at the demo. Enable duplicate. And now, because we ordered a VM a few minutes ago, it should have kicked off a runbook that will go ahead and do step 1. So I think I pressed the wrong one, but it should have created a job in Azure Automation now that will invoke the first part before the approval process. So here we can see that our runbook was initiated about 10 minutes ago, and it's finished. So let's go ahead and look at that one. So this is basically part 1, where it decides what operating system it will have, what the name of the virtual machine will be, and so on. So here you can see that the runbook completed. If there are any errors or warnings, we can go into those streams, but we can go into output. This will basically show you the same output as when you run the script in a PowerShell console. So you can see that the output pane looks pretty much like a PowerShell console. So if you go into the top here, you can see the information that the deployment script is outputting. For example, the service request ID from Service Manager, what user created it, who should be the owner of the VM, configuration info. So here is a PowerShell object created based on data from a JSON file. Because I selected Windows generic as the server role, it will get all of these settings. So the configuration type is Windows DSC, for example. If this was a Linux generic, for example, it would get Ansible, for example, in this case, and then it will kick off some Ansible runbooks, playbooks to configure the server. Here we define the images to use for Azure, if it's a dev or a test, the on-premise image to use in Virtual Machine Manager, the VMM hardware profile to use. So if you are going to do some changes on the hardware profile, for example, for this server role, you want it to have 4 gigs of memory instead of 2 gigs. Nothing of that is hard-coded in here. You can just go into VMM and change the profile there. So it's the goal here was to create a dynamic solution that is not, it shouldn't have too much hard-coded. Here you can also see the computer name prefix. So this is the prefix for this server, and based on that it will add a location code and a sequence number. So the server will be called demo SRV and OSL for Oslo in this case, and 01 or 02 or whatever is the next available one. Then we can see in the end that the approval is needed for this deployment. So the runbook will go into the service request in Service Manager and trigger an approval process. So it will just do nothing before that is completed. Then we can go ahead and actually do the approval. So if we go back to the case and to activities, we can see that stage 1, which ran the first runbook, it's completed. Now we can go into the approval process. And here you can have some in the template, you can configure some default reviewers. So for example, a couple of people in the operations department can be on this list by default so that they will get an email, for example, that they have to approve an order. In this case, I'm just going to approve it manually. And when I've approved this, after a minute or two, when the Service Manager workflow kicks in and actually triggers the runbook, it will trigger step 2, which is the invoke PSVM deployment stage 2. That will actually go ahead and do the installation. So I can see if I have any of those historically that we can look at. This is stage 2 and it's completed. So let's have a look at the output. Let's go to the top. Here you can see that it's getting the deployment config because the runbook gets what's called a runbook ID, so it can look up in Service Manager and get the information about this specific order. Then it gets the same deployment config that was generated by the first runbook. Since this was production, it will deploy it using Virtual Machine Manager. And that will take a few minutes, and when that's finished, it will spit back the deployment results, such as the IP address and the VM name. Then it will send some notifications to email and also to Slack. So here is an example from Slack from the Crayon demo environment. It will send a notification here. So if you are on Slack, you can see when new virtual machines are deployed, basically. Then it will register the machine in Service Manager. It will create a security group in Active Directory called local admin and underscore the server name and add it to the local administrators group. It will also install BG info on the machine. I can show you quickly if I have it up and running here. If you find that machine in Virtual Machine Manager, I think it's this one. We should see that BG info is indeed installed, so it will be visible for all users. Here you can see at the top, here is the BG info template that we applied, and also we added a custom field to BG info called system owner that will basically get the name of the user that is owning this VM, and that's based on information from Service Manager or the CMDB. So this is actually something that we are going to configure to run every day, so that the system owner info in BG info is updated or synced with Service Manager every day. So when you log on to, let's imagine you're an operator and log into a server with some problems, you can instantly see who owns the VM without looking up in some database. Here you can also see other things that is configured. For example, we can see that the local configuration manager is configured to talk to Azure Automation DSC. We can see that in the local administrators group, the local admin ID group for that server was added. And we can also see some firewalls rules created by DSC. I always append created by DSC in parentheses, so I can see what rules is created by DSC. Then it will invoke the VM configuration. So this will basically invoke the DSC runbooks that are created and apply a configuration based on the server role. If Windows Management Framework 5 is not installed, it will also do that and reboot the server, and it will add it to Azure Automation DSC and assign a configuration. So if you go back to the front page, I can quickly show you the DSC. Here you can see on DSC nodes, you can see the servers that have been registered to the system. You can also go into, for example, this one, and see some details about the state of the machine. I think this is pretty new, the reporting feature they have in DSC. So instead of having to manually use PowerShell and detect how the machine is with regards to DSC, you can go into here, have a look at the latest consistency check, and you can see what configuration it got, the 2012 R2 generic configuration. You can go down here and you can see on an individual resource level how if the node is compliant. So for example, if the power plan is set to something different than the configuration, you will see that it's non-compliant here. So you can go into power plan, for example, and see that it's indeed set to balanced as I set in this configuration. In this case, I only have one configuration in the setup. So I can quickly show you that. If we go into DSC configurations, we'll see that we have this 2012 R2 configuration here. And inside here, we have some, you can see the deployments to the pull server. So for each time we update the configuration, you will see that it will run a compilation job. And here you can see what configurations is here. So here you can see that I only have one configuration for the Windows generic one, but what we want to have here is one for each role, Windows web server, and so on. But basically we haven't implemented that yet because we are waiting for Azure Automation to support composite resources, which would also be around January, February. So they are constantly adding new features. All right, let's have a look before wrapping up at the state going forward now. We still want to build those DSC templates for the application owners, but that's something we can't do on our own. We have to talk to the application owners and see what the settings they want to have by default. But a good starting point would, of course, be to look at the group policies and create, for example, a dedicated organizational unit in Active Directory for DSC managed computers, and just continue to use what is there for group policy managed ones. And we also still want to think about more robustness and the structure, for example, the testing framework and the build server and things like that. But I think that we are getting pretty good progress from where we started and going forward. I also have some discussion points here that we don't have time to discuss now, but if you're interested, feel free to come up to me afterwards or in the expo area, and I'm more than happy to discuss configuration management further. Contact information at Twitter at Egil Ring. You can find the slides and demos. They should be up by a scheduled tweet by now, where you can find all of the slides and the demos that I showed you, and also a few other resources here. So I think that's the end. Thank you very much for attending.